Everyone, in this we are going to understand how the full and empty flags are generated in a FIFO and why the logic is different for synchronous and asynchronous FIFOs. First, let's start with the basic. A FIFO has two important pointers. The write pointer, which tells us where the next data will be written, and the read pointer, which tells us where the next data will be read. These two pointers are used to determine whether the FIFO is empty or full. First, let's understand the empty condition. A FIFO is empty when there is no data available to read. In a synchronous FIFO, both pointers are updated using the same clock. Since they are in the same clock domain, they can be compared directly. So the empty condition is directly write pointer equal to read pointer. This means if both pointers are equal, there is no unread data left in the FIFO. Now let's understand the full condition. A FIFO is full when all memory locations are occupied, meaning there is no space left to write new data. So we might wonder here, if both pointers become equal when the FIFO is full, how do we distinguish it from the empty condition? The answer is an extra pointer bit. The write and read pointers are usually one bit wider than the address width. This extra bit changes every time the pointer wraps around the FIFO. So when the FIFO becomes full, the address bits of the write and read pointer are the same, but the extra most significant bit is opposite. That's why the full condition in a synchronous FIFO is written as write pointer equal to naught of read pointer MSB most significant bit and read pointer rest of the bits. Here the address bits match, but the most significant bit is inverted. This tells us that the write pointer has completed one more loop than the read pointer, meaning the FIFO is full. Now let's move to the asynchronous FIFO. The biggest difference is that the write and read side do not use the same clock. For example, the write side may run at 100 MHz, while the read side may run at 50 MHz. Since the clocks are different, the write pointer can change while the read side is trying to read it. If we compare the pointers directly, the comparison may become unreliable because of metastability and timing issue. To solve this problem, asynchronous FIFO use gray code. The gray code has a special property. Only one bit changes between consecutive values. This greatly reduces the chance of incorrect pointer sampling across clock domains. In addition, each pointer is passed through synchronizer flip-flops before being compared in the other clock domain. So the empty condition becomes write pointer gray sync is equals to read pointer gray. Here we notice that the synchronized write pointer and the local read pointer both are in the gray code. If they are equal, the FIFO is empty. Similarly, the full condition is write pointer gray equal to naught of read pointer gray sync 3 down to 2 and read pointer gray sync 1 down to 0. This follows the same idea as the synchronous FIFO. The address bit is still matched, but the upper gray code bits are inverted to indicate that the write pointer has wrapped around and the FIFO is full. That's the key difference between synchronous and asynchronous FIFO full and empty flag generation. Thank you for watching and see you in the next video.